Hello everyone, I'm Aylin. Just like every Thursday, we are here again this week with a new topic, which is smoke detection and area protection at critical spaces. So let's begin. So this week's webinar titled Smoke Detection and Area Protection in Critical Areas will address the correct detection approach in areas with a high risk of fire or where operational continuity is paramount importance in the event of a fire. Early detection of smoke in critical areas such as data centers, electrical rooms, panel rooms, archives, or warehouses. Another example, technical areas and similar locations is crucial for life safety and critical equipment protection, also operational continuity. So in this session, we will evaluate smoke detection methods in critical areas and the selection of the correct detector selection and according to the structure of the area and placement criteria. Also key points to consider for comprehensive area protection. Yes. So first of all, in areas containing valuable assets such as historical artifacts, data processing rooms, archives, libraries. In these type of areas, early detection of a fire in its initial stages is critical, as you know. So the selection of fire detection systems in critical areas should not be based on a standard approach, but rather on the risk profile of the area. So each area, such as data center, archives, boiler rooms, panel rooms, has different fire risks and environmental conditions and also detection needs. Therefore, point-type smoke detectors or multi-sensor detectors, aspirating smoke detection systems, or heat detectors, flame detectors, gas detectors, and like this linear type heat detection systems should be chosen according to the appropriate scenario. So first of all, aspirating smoke detection systems, this is one of the most preferred solutions in critical areas. So it continuously draws the ambient air through the piping system, the holes into the device, and analyzes it very precisely. So it is used especially for early smoke detection in data centers, server rooms, telecommunication rooms, archives, libraries, museums, and such these containing high valuable equipments and high valuable assets. The other one is linear type heat detection systems, cable type heat detectors in other words. These solutions are used to detect temperature increases along a long line. So they can be preferred in cable galleries, conveyor lines, power tunnels, parking lots, maybe industrial facilities, and such and hard to reach areas. So these cables are non-flexible, so we cannot change it, we cannot repair it, so we should use it hard to reach areas. So effects of environmental conditions on detections. The first one is airflow, high ceiling, low temperature, dust, humidity and steam, raised floor, suspended ceiling, shiny surfaces and light sources, and last one is obstructions and decorative elements. So, detection selection according to room type is, first of all, data centers is aspirating smoke detectors, point type smoke detectors, and raised floor detection can be used. In cold storage facilities, aspirating smoke detection again can be used, and special piping, low temperatures are the suitable solution. And the other one is electrical panel room. In electrical panel rooms, we can use aspirating smoke detection system again. So aspirating smoke detection can be used in every type of environment. So smoke detectors again can be used, and panel interior detection can be used. And we have boiler rooms, another different type of environment. So in boiler rooms, dust, humidity and steam exist. So we can use gas detectors, heat detectors and X-proof products, but not the smoke detector or aspirating smoke detector. So these two are detecting smoke. So the dust or humidity can affect harmful for this type of detectors. And we have archives and museums. So this type of areas, very early smoke detection is needed, is critical. So minimum intervention time is needed again. So we can use aspirating smoke detection systems again. So in conclusion, in critical areas, environmental conditions directly affect the detector performance. You can see from here, so airflow can delay the arrival of the smoke to the detector. In high ceiling spaces, the ceiling can affect the time it takes for smoke to reach the ceiling and detector. In low temperatures, it can affect smoke movement and also device selection. So the detector should not be affected by the cold air. For dust and humidity and steam, it can increase the risk of false alarms. The other one is raised floors and suspended ceilings. It may also create a need for detection in hidden spaces in obstacled areas. So shiny surfaces and light sources can affect the flame detectors. And of course the obstacles and the other elements can affect the detector selection. Yes, the most important one is aspirating smoke detection system. So we can see the system usage. So there is a pipe and sampling pipes, and on it sampling holes. So what is it? In these systems, ambient air continuously drawn through a special pipe network and analyzed by high sensitivity laser detectors, laser sensors. So the system first of all actively draws in air and analyzes smoke particles and detects very low levels of smoke, and it generates an early alarm. So therefore it is also defined as a very early warning system. So why is it preferred in libraries or another type data centers? It provides very early detection, protects critical areas, and effective in areas with high ceilings. These are the most important three. So let's look at the placement of aspirating smoke detector. So we can use it one single pipe, and it can placed at like this, and it can be maximum of 150 meters. The other one is two pipes. We can use a T connection apparatus, and we can divide it two pipes, and we should use ending caps both of these pipes. And the other one is four pipes. We can use 1, 2 and 3 T apparatus and divide into four parts for the area, and it can be maximum of 400 meters. Each one of them is 100 meters, and this is the 125. This one is 125 meters each one of these. So the use of aspirating smoke detection systems in libraries is one of the most effective solutions for protecting both human safety and also cultural heritage by enabling the very early detection of the fire. So these systems offer significantly higher protection performance compared to conventional smoke detectors, especially in archives and also valuable artifact areas. So as you know, the other important point is cold storage facilities. So the aspirating smoke detector smoke detection is preferred for providing early detection in low temperature and challenging the environmental conditions. So however, air taken from the cold environment can create problems due to the condensation, icing, or humidity as it is transported to the aspirating smoke detector device. Therefore, a heating unit used in the sampling line or at the device inlet helps the system operate more stably by ensuring that the taken air reaches the device under appropriate conditions. So let's talk about the key benefits. So first of all, it reduces the risk of condensation and icing. Low temperature air from the cold storage facility can create condensation, as you know, so when it reaches a warmer area or device inlet. So the heating unit reduces the risk, preventing the moisture or icing related problems in the pipeline and device inlet. Second one is maintains the air sampling continuity. So the basic operating principle of the aspirating smoke detection system is to continuously sample the ambient air, as you know. And thanks to the heating unit, the airflow remains more stable, and pipe blockage, freezing, or moisture-related flow problems are reduced. The other important point is reduces the risk of false alarms and malfunctions. We can prevent the condensation, moisture, or icing. So it can affect the sensor performance and causes the airflow malfunctions, and we can prevent it. So the heating unit reduces these effects and contributing to more reliable system operation. Supports the device performance and detection sensitivity. So the fact that the air sample reaching the detection cell, the device, arrives under more controlled conditions and increases the measurement stability. And this is a significant advantage, especially in cold storage facilities. And then we have, it can reduce maintenance needs and operational downtime. So reducing the failures, it's caused by humidity, icing, or clogging. So it means less intervention, more consistent operation, and lower operational downtime. Let's talk about the benefits of using the aspirating smoke detection systems in very dusty environments, as you can see. Choosing a fire detection system in very dusty environments is critical, so to reducing the risk of false alarms, as you know. So aspirating smoke detection systems continuously draws the ambient air through the piping system into the device, and it analyzes it. Dust and dirt filters the auxiliary equipments of the aspirating smoke detectors. It prevents particles in the sampled air from directly reaching the detection cell and contributing to more stable system operation. So this reduces the risk of dust-related contaminations, also false alarms, and device life, device performance. So you can use this as a point in your area. So benefits of using aspirating smoke detection in very dusty environments. The detection cell is protected thanks to dust and dirt filters, and the air drawn from the environment passes through filters inside the device, and it is analyzed. So the structure reduces the contamination and also the risk of false alarms. So since the direct access of dust particles to the detection cell is limited, and the probability of dust-related false alarms is reduced. And we have early smoke detection performance. So thanks to its filtering structure, the dust filters, magnetic filters, or heavy-duty dust filters, the device can continue to detect smoke accurately even in challenging environmental conditions. Then we have maintenance process become more controlled. So system performance can be maintained by regularly checking, continuously sampling, and replacing filters when necessary. So it provides effective protection in hard-to-reach areas. So thanks to the piping system, air samples can be taken from the areas with high ceilings or shelves, thus or where equipment placement is difficult. So how is the system repairing process? So it is very easy, by the way. We can use air pumping equipments for this type of pipes, and it provides area protections. So this involves not only monitoring the risky area with detectors, but also early detection of fire and also accurate transmission of alarm information, activation of relevant systems within the scenario, and acceleration of the intervention processes. Secondly, alarm scenarios. So pre-alarm, fire alarm, early warning to authorized personnel, and alarm information and general warning to the control panel. So HVAC control, we have HVAC control. It stops or redirecting the ventilation. And we have door access control, so safe passage scenarios, fire suppression system integration. So it can integrate with gases or panel-mounted fire suppression systems. And also graphical monitoring for monitoring the fire point via software. The other point is reducing the risk of false alarms, as we mentioned. False alarms are also a significant problem in critical areas, so because unnecessary evacuation, production stoppage, or incorrect triggering of the fire suppression, fire extinguishing systems. It can have serious consequences. To correct detector type selection, sensitivity adjustment according to ambient conditions, and filter and maintenance checks, and consideration of airflow, correct configuration of fall alarm levels. The other point is maintenance and periodic checks. So in critical areas, simply installing the system is not enough. Its performance must be maintained through the regular maintenance and testing, so especially for aspirating smoke detector. So filter check, airflow check, pipeline and sampling hole check. Also we should test the alarm levels, and device and control panel communication check should be performed. Yes, that's all for today. Thanks for your participation. Next week we will be meet again at 11 a.m. See you.